This will be for the con assignment, properties of density curves. Okay, it says the density curve below represents the number of minutes Anastasia takes to go from her chemistry class to her Spanish class. And they want to know, what is the height of the density curve? Okay, so the thing you want to understand here is that this, I know it's not really a curve, but this curve represents 100%. Okay, and of course, if you convert 100% to a decimal, that just equals 1. So the area of this triangle is just 1. Okay, and recall that the area for a triangle that is going to be 1/2 times the base times the height. Okay, and remember, the base and the height are always perpendicular to each other. They make a right angle to each other. All right, so we're going to set our area equal to 1. All right, and then we can plug in some values, or just one value actually. Okay, so this is going to equal 1/2, and the base of this triangle goes from 1 to 5. Okay, of course, 5 minus 1 is just 4. So the length of the base of this triangle is just 4. And the height of this triangle, we don't know. That's what we're looking to find. Okay, the height would be this length right here. If you went straight down and made it perpendicular to the base, this right here would be the height of the triangle. Okay, so that is going to be h, and that equals 1. Okay, 1/2 times 4 is just 2, and we still have h, and that equals 1. Okay, dividing both sides by 2, 2 over 2 cancels, and h equals 1/2. So you just enter that in the box, 1/2. All right, so here in the box for the height, you just type 1/2, or you can do 0.5. Now, I just want to mention, if you want to get rid of the 1/2 before you plug in for B, okay, you can just multiply both sides by 2 at the very beginning, okay, and 2 times 1/2 will cancel, and you'll have BH equals 1 times 2, and you'll get the same answer. All right, consider the density curve below. Which of the following statements are true? Okay, so the first one answer is the median of the density curve is 3. So remember, when you have the bell curve, like so, and it's symmetrical or the same on both sides, the mean and the median are just going to be right down the middle. Okay, so that line right down the middle, that's going to be the mean, and it's also going to be the median. All right, so as you can see in this density curve here, it's the same on both sides. It's symmetrical. Okay, so if we went like this, right down the middle, this would be our mean, and this would also be our median. Okay, so that's going to be 3. Okay, you can see it's exactly the same on both sides. So right down the middle is the median, and A is true. Answer B, it says choose all answers that apply. Answer B, the area underneath the curve is 0.5. Okay, we know that's false. All right, we said it in the first problem. This represents 100%, which is just 1. So the area is just 1. So B is false. Answer C, the height of the density curve is 1/3. All right, let's see if we can calculate the height. Just like we did in problem 1, we said the area of a triangle equals 1/2 base times height. Okay, and the area is 100%, which equals 1. All right. So that's going to be 1/2. And for the base, it runs from 6 to 0. Okay, so obviously our base is just 6 minus 0. Okay, so the base is going to be a 6. And the height would be this distance right here. Okay, perpendicular to the base, this would be the height. And we don't know the height yet. Okay, and that whole equation, that whole setup equals 1. All right, 1/2 times 6 is 3 times h, and that equals 1. Dividing both sides by 3 in order to solve for h, the 3's cancel, and h equals 1/3. So is that what it said for answer C? The height of the density curve is 1/3. Okay, we just proved that to be true. Okay, so it's both A and C. All right, be careful of the ones that say choose all answers that apply. There may be more than one. All right, the density curve below represents the number of minutes after the lady's alarm clock rings that she rises from bed. Okay, so here we have a rectangle, but it's still going to have an area of 1. Okay, which of the following statements are true? The mean and median rising times are equal. All right, I'm pretty confident that A is true. Again, because this is basically symmetrical, you can divide it right down the middle. Okay, right at the 2.5 mark. So I am pretty confident that the mean and the median are both right down the middle. So I am going to say that is true, that they are equal. All right. Part B, the distribution of rising times is skewed to the right. Well, clearly that's false. Okay, whenever something is symmetrical or the same on both sides, it is not skewed. All right, skewed to the right would be something like this. It would have a tail on the right end. Okay, if it were a triangle, it would be something like steeper on the left and then less steep on the right. That would be skewed to the right. Okay, but this is nothing like that. It's even on both sides. So B is false. Answer C, the height of the density curve is 1/5. Okay, so recall we said this represents 100% or an area of 1. Okay, we know that the area of a rectangle is just length times width, or base times height. Okay, and the area equals 1. So our base of the rectangle runs from 0 to 5. All right, and of course the distance from 0 to 5 is just 5 minus 0, which is 5. Okay, so for the base, we have 5. For the height right here, We don't know the height, so we're going to solve for height. And that equals 1. Okay, dividing both sides by 5. 5 over 5 cancels, and the height is 1/5. So, answer C, the height of the density curve is 1/5. That is true. Okay, just to check my answer for part A, it says in a perfectly symmetric distribution, the mean and the median are equal. They both can be found at the exact center of a symmetric distribution. So that's what I said. Since the distribution of rising times has a uniform distribution, is also symmetric. So both the mean and the median would equal 2.5 minutes. So that's what we said. Okay, consider the density curve below. We have a triangle. Which of the following statements are true? The density curve is left skewed. All right, let's see. If we were to draw a line down the middle at the peak, clearly we see more of the area is on the left of that line than the right. Okay, and you can see this side here on the right is more steep. The side on the left is less steep. Okay, so clearly the tail is on the left. That makes it left skewed. So answer A is definitely true. It's left skewed. Okay, answer B, the mean of the density curve is greater than the median. Okay, recall in the past, we said that the mean is pulled toward the tail. Okay, so if it's less steep on the left-hand side and the tail is on the left, that means the mean is going to be more to the left of the median. Okay, the median will probably be somewhere around here, and then the mean is probably going to be somewhere around here. Okay, the mean gets pulled toward the tail. So clearly we can see that the mean is less than the median. All right, so answer B says the mean is greater than the median. That is false. Answer C, the median of the density curve is 6. All right, let's take a look. In order for 6 to be the median, remember that the median is the halfway point, okay? So let's see if 6 is the median. If 6 were the halfway point, the area of this section of the triangle, remember the whole triangle, the area equals 1. So the area of this section would be 1/2. And the area of this section would be 1/2 if 6 were the median. Okay, so let's see if that's true. So we said before the area of a triangle equals 1/2 base times height. And in this case, the area of the whole triangle is just 1. Okay, so the base runs from 7 to 3. Okay, so the length of the base is going to be 7 minus 3, which is 4. So that's going to be 1/2 times B, which is 4, times H. And that equals 1. Okay, 1/2 times 4 is 2, times H, and that equals 1. Dividing both sides by 2, we can see the height equals 1/2. So I am going to draw that on the triangle. This height right here, going right to 6, that equals 1/2. Okay? And now I can calculate the area of this triangle right here. Okay, that's 1/2 base times height. Okay, that's going to be 1/2 times the base. Okay, this of course is perpendicular. This base right here just goes from 6 to 7, so that's a base of 1. And we said the height was 1/2. So we have 1/2 times 1 times 1/2. Okay, so that's going to be 1/4. All right. So that makes the area of this triangle 1/4. And then the area of this triangle here would be 3/4. All right. So there is no way that this could be the median. Okay, because it would have to divide the triangle into 2 equal halves. All right. Now, was all this necessary? Probably not. Okay. If you just drew the median at 6, clearly you can see that this area is greater than this area. Okay. If 6 were the median, they would have to be right down the middle. And this would have to be 1/2 and 1/2 on both sides. So I probably did some unnecessary work. Anyhow, the median is definitely not 6. So the only answer is A.